And let's look at the page 567, problem 38. So we try to solve the sine of the x over 3 plus 1 equal to 0. So first, we try to isolate this sine function so that we can have an equation of the form sine x equal to a. So we move this one to the right side. Then we have the sine of x over 3 equal to -1. So this is just like the equation sine of y equal to -1, right? And we know the general solution for this equation is the y equal to 3 pi over 2 plus 2k pi, because between the 0 and 2 pi, the special solution to this equation is the 3 pi over 2, right? Cosine or sine of the 3 pi over 2 is equal to -1. So now, by using this general solution, we may just treat x over 3 as the y. Then we have the x over 3 equal to this general solution. So that is the 3 pi over 2 and plus 2k pi. Then to find the general solution to this equation, we multiply both sides by 3. Then we have the x equal to 9 pi over 2 plus 6k pi. And then this is the general solution. So if you can write the solution set, that is a set of x such that x is equal to 9 pi over 2 plus 6k pi. Now, let's look at one more example about equations involving multiple angles. And this example is a little bit complicated. So let's go to the page 567. And let's look at the problem 70. So we have the cosecant x minus root of 3 equal to cotangent x. So by now, we have been dealing with the equation involving only one trig function, right? But for this one, we have two trig functions. One is the cosecant, another one is cotangent. So in this case, we try to convert this function to one function which only involves one trig function. So you have to use the relationship between the equations which appear in this, between the functions which appear in this equation. So how do we relate cosecant to the cotangent? How? Yeah, the Pythagorean identity, right? So we have the cotangent square plus 1 equal to cosecant square, right? So that means if I want to convert this equation to one equation which involves only cosecant function, then I need to do what? To do what? If you want to use this Pythagorean identity, what should you do for this equation? Square, right? Square the both sides. So now let's just square the both sides. And then we have the square of the cosecant x minus root of 3 equal to square of cotangent x. So let's expand this left side. We have the cosecant square x minus 2 times root of 3 cosecant x, and then plus the square of root of 3, which is the 3. Now, let's replace this right side. See, from this Pythagorean identity, we have the cotangent square equal to cosecant square minus 1. So now, let's replace this cotangent square by cosecant square minus 1. Then we have the cosecant square x minus 2 times root of 3 cosecant x and plus 3 equal to cosecant square x minus 1. Now this cosecant square and this cosecant square cancel, right? So you have the negative 2 times root of 3 cosecant x. And let's move the 3 to the right side. You have the negative 4, right? And then let's divide both sides by negative 2 times root of 3. So you have the cosecant x equal to 4 over 2 times root of 3. And this negative sign cancel, right? So you have positive. And then you have from here, you have the cosecant x equal to 2 over root of 3. And we prefer the sine and the cosine. So let's use the identity, okay, the reciprocal identity, to change this equation to the equation involving, okay, the sine. So we know that is the 1 over sine x equal to 2 over root of 3. Now, let's get the reciprocal of the both sides. Then we have the sine x equal to root of 3 over 2. So now, from this equation, we arrive at this simple equation, right? So now we can solve this equation by using the steps for solving the trig equation involving the sine function. So first, let's get the first special solution. So we know we have the inverse sine of root of 3 over 2 equal to pi over 3, right? That's simple. And then we get another special solution between the 0 and 2 pi by using the pi minus this pi over 3. And then you have the 2 pi over 3, right? So actually, you look at this fig. So this is the pi over 3, and then this is the 2 pi over 3. Right? So use the pi minus the pi over 3, you have the 2 pi over 3. Now, after we find these two special solutions, then we need to check them, okay? We need to check them because we square the both sides. And when we square the both sides of an equation, this may cause the extraneous root. For example, we have the x equal to negative 2, right? This simple equation. And actually, we already have the solution, negative 2. If I square the both sides, then I have the x squared equal to the square of negative 2. So if I move this to the left side, I have the x squared minus the 2 squared, right? Because square of negative 2 same as the square of 2. So now let's factor this. Then you have the x minus 2 times x plus 2. Now you solve this equation, then you have two solutions. One is this original, okay, from this x plus 2 equals 0. Another one is the x equal to 2. This x equal to 2 is an extraneous root. Which is not a root to this original equation.